Hi, my name is Mark Anderson. I'm a professor of architecture at the University of California, Berkeley, and a principal in Anderson Architecture in San Francisco.
And I'm Peter Anderson, Mark's brother, and also principal in our firm together. And I'm a professor of architecture at California College of the Arts in San Francisco. We're pleased to have this chance to share a few thoughts. We've been overviewing the different materials that have been shared with us about the Lighthouse program. And we have a few observations, and it's a very interesting program that we've enjoyed learning about. The project is very ambitious on many scales, but what particularly impressed us is the scale of the implementation. This is far beyond the usual exploration of new technologies at a small scale. By implementing at a larger scale and in multiple locations and with multiple technologies at once, it's a truly remarkable exploration that allows a cross comparison in a remarkably short time of the 1-year building period. So we've enjoyed studying these a little bit, getting to know them a little bit, and learning about the differences, all of the technological approaches. And as we went through the systems, we got a chance to understand that there are great similarities in some ways to the approaches, even though the end results are somewhat different in the technologies used. So after having a chance to look through them, we realized that we really wanted to compare on a finer grained scale. So we started by putting them together into a matrix where we could study the different systems of foundation, primary structural and vertical loads and horizontal loads, primary wall structures, and compare them. And then to go through and look for the similarities and the differences. For instance, in this one, we're looking at which ones use cast in situ concrete, which is a very particular technology, a site building technology. So we did that looking at a number of the different issues. The other part that we think is very interesting is there's a very well developed and clear 10 stated project goals for this. And we started to look through the projects and imagine that a future process could be going through to rate the projects for each of the, for their conformance with the stated project goals. And then an additional part of this, we started, as we went through that, we started thinking of additional goals and aspects that would be very interesting to study. For instance, the CO2 emissions and carbon sequestration performance of the projects, and the use of renewable resources and industrial agricultural waste, the opportunities for contribution to regional economic opportunity, creation of employment opportunities, quality and safety of working conditions, and perhaps most importantly, a comparison of the quality and comfort of life for the inhabitants of the units once they're made. So these are all things that could be explored in further analysis.
So after going through and understanding a little bit about all of the ambitions and the processes in the Lighthouse project, we started to think about what are the possible next steps that we can learn from Lighthouse and plan forward on how to build from here. So the first issue is certainly to look for the lessons learned and to build upon the approaches in the Lighthouse project, so that all of the great progress that has happened so far can be harnessed and continued. The second issue that seemed really valuable to us would be the potential to mix some of these systems in order to create higher efficiencies using some of the best aspects of each of them. For example, taking perhaps precast plumbing modules that are being, they could be built in the same volumetric modular system as the Ranchi system, and use those as some of the tunnel formwork that's being used in the monolithic concrete casting in the Rajkot system. Or, for example, taking panelized insulation, as is being used more in the indoor system, and applying that in the stay-in-place formwork at Lucknow. And there are quite a few other possible mixes that could be really positive. The other aspect that seems really important is to continue to reduce the quantities of concrete. This would reduce the carbon footprint and reduce the energy consumption in the project. The other outstanding issue would be to continue to look for ways to increase the thermal efficiency and to increase the interior-exterior human comfort in the buildings. A lot of prefabrication is being looked at, but I think there's a lot of opportunity to take the offsite prefabrication even further, so that using a varied array of offsite fabrication panels, assemblies, modules, taking these and applying them so that there's less work on the job site where it creates additional waste and pollution, congestion and disruption in the neighborhood, and so forth. This would also need to increase the system flexibility, because when it's built off site, you have to have flexibility so that you can still optimize for specific local climates and local materials, and for being able to harness labor skills and really generate local employment as well. So the other thing that stood out to us is that a number of the projects rely on a certain amount of imported proprietary technology, and we think it would be very valuable to keep pushing the technological study so that more of the technology would become internal Indian-owned technology, not reliant on outside proprietary systems. And then finally, I think there's a lot of opportunity to continue further in pursuing renewable resource materials, reducing the reliance on cast-in-place concrete and looking for opportunities possibly with biomass or other recyclable, renewable resources, so that we'd really reduce the energy and environmental impact of the projects.
So one of the big challenges facing the world is the global warming and the great release of carbon dioxide into the atmosphere. And in our other work, we've been doing a lot of projects where the main goal is to reduce the use of products and materials that release carbon dioxide into the atmosphere. Concrete and steel are both some of the largest emitters of CO2. There are other alternatives that could be explored and used in combination to reduce the amounts of steel and concrete used in those.
In addition to the environmental impacts, the other really major goal in a project like this needs to be the increase in efficiency in the entire construction process. And we know that's already a big part of the push in the Lighthouse project. And this is not just an issue in India. This is something that's a much studied problem around the world. Everywhere, the construction industry is very much behind every other sector in the economy and every other manufacturing sector. There's a lot of potential to make some very significant increases in efficiency and production capacity in the construction sector. So now we thought we'd show you just a very few examples of some of the projects that we've worked on, especially in similar sorts of ambitions to increase efficiency, increase sustainability, reduce energy consumption, and create high qualities of life in dense housing projects. So a lot of this relies on analytical, environmental performance modeling using advanced analytical tools, so that there can be modular applications, but really tuned to the unique atmosphere and climate of each local site, so that you can do self-shading and a number of things just in the building form and the way that you compose the modules. So another part of our work is very much on streamlining the design and construction process through the use of BIM, or building information modeling, and parametric design, so that there are very efficient uses of every amount of data throughout the system, and the organization of that through the modeling process. The other thing that we're very interested in, engaged in, is infill housing of dense housing into existing neighborhoods. And that again requires both the efficiency of offsite fabrication and the ability to be flexible and to adapt to specific, more complex site conditions. This involves modular, panelized, and a combination of systems, but especially a certain layering of the components, so that we can be able to customize a little bit with different shading elements, different component pieces, a kind of mix and match approach to being able to tune the project to a specific site, a specific climate and group of people. So this involves taking even very simple modules, but essentially dressing them for a certain orientation and application in different site conditions. There isn't really a one-size-fits-all that can really be entirely optimized in terms of environmental performance and comfort. You really have to have a certain adaptability. So a reliance on big scale modularity and very efficient base construction, but still with a lot of elements of individualized capacity. So this is one example of a project in New York that we've been working on. It's a mass housing project with a lot of dwelling units, but this all works with just two basic steel modular, volumetric modular components. So we're able to very efficiently manufacture these components, and yet adapt to the topography and the site conditions, and make quite a number of very different looking types of units and building configurations. So you can see that these are very adaptable and very unique in form, even though the pieces are absolutely the same in every unit, or in every composition. So having modularity can be very systematic at the production level, and still give a lot of customizability at the macro scale of the building site. So the same sort of flexibility is something that we've been looking at the level of the individual pieces of the building. And this means in some cases having a mix of volumetric and panelized systems, so that you can very easily do maintenance and renewal and remodeling within the system without throwing anything away, so that there's always a kind of an ability to have the production of the primary structure be renewed, even though, or be contained and reused, even though a good deal of the componentry can be changed out over time or easily upgraded as technology changes. So these are very much the kinds of issues that we are interested in. These are the kinds of issues that the Lighthouse project brings up as potentials. It's things that are already being worked on in the Lighthouse project. And we would be excited to get involved further beyond the kind of summary review of it, and really tinker with the parts and think about how the technology can incrementally increase in efficiency and livability and quality of life for the people who live there and work on the projects.
So thank you for this opportunity. Thank you for sharing the information with us. it's an exciting project, and we look forward to learning more about it and working together with any of you in any way that we can. Thank you again.
Right.